Hello. In this video, we're going to continue to talk about bubble sort, and specifically, we're going to talk about a little the optimization that we seen before, and also it's time for you to try to write some code. All right, so let's get started. Now, actually, before we even talk about optimization, one thing I want to say is, whoops. Um, um, I've said this many times. I've emphasized the importance of testing, right? And especially with something this is a sorting algorithm is something that is really non-trivial. It's actually pretty complicated. So if you think about this, this is a loop inside another loop. So it's a nested loop. It can get it's not simple, right? So it's important that once you have an implementation, or sometimes even before your implementation, but anyway, now that we have an implementation, we have to test it, right, to make sure it works. And remember what I said previously in one of the previous videos is that when we test, uh, when when our code is dealing with the list, there are all sorts of lists that we really should kind of handle, right? We really should handle a list with no elements. It's empty, right? I actually said we should really deal with a list that has one element. So why don't we do that? LST, I'm going to actually create a list with nothing and make sure that works. Okay, I'm going to call this a list 0. Ooh, and that changed this one. That's not good. Anyway, um, so and okay, so I have a list. I have an empty list. I have a list with one element. I have a list with multiple elements, but this one is actually it's already sorted. I just want to make sure if for something that's already sorted, it doesn't mess it up. And then I have a list that's kind of random, the example we used last time. And then finally, I have a list that's actually sorted already, but in the descending order. I just want to, for kind of just want to make sure that for a list like that, we can still sort it in the ascending order. All right, so let's run this, make sure all of them do work. So empty list, we get an empty list back. That's good. List with one element, we get that one element back. That's great. For something we already sorted, we didn't mess it up. For something that's kind of random, we have it sorted. And then for something that's sorted but in the completely opposite order, we sort it again correctly. So this gives us the confidence that whatever we did um, has looks pretty good. It seems to work in most cases, in all cases that we tested. So that's good. So that's about testing. Now, um, here's the main topic for this video: optimization. Right? Remember, we said that optimization number one is that in round one we bubble the largest to the top. In round 0 we start at 0. In the second round, in round one, we bubble the second largest to the top, but not all the way to the top because the top is occupied by the largest. So we can pop, bubble it to the top minus one, right? One before the top, or yeah. So and then in the next round we bubble the third largest to the top minus 2. So right? So the optimization, if you remember, is really the list that we have to bubble through in each run. Kind of, it gets smaller, it shrinks by 1. So what that means is that if we look at flow largest to the top, every time we should tell it, what is the maximum size that it should sort in that list. So what we actually do then would be, I'm going to give it a size, right? In the original, remember, we always go through the entire list. So we don't want to always go through the entire list now. I'm going to give it a size. So instead of always the entire list, I'm going to say a size here. Okay, so I introduce a new parameter. Well, then we have to figure out what to put in the parameter, right? Now, the first to get back to what we had before, remember what we had here was just the length, uh, length right here. So we still start with size being the length, and the length of the list, and then we can put the size here. Now, so that's that. And remember though, we have to shrink the size by 1 every time. So it's fairly straightforward to shrink the size by 1 every time. We just, after we're done 1 round, we just subtract 1. Okay, so we make these changes, and the good thing is, it looks kind of reasonable, but again, we really have to test it to make sure that it works. Right. The good thing is we already have a test case. I mean, we already have 5 test cases. Let's run through all of them, and hopefully we get exactly the same result back. Okay, empty, 1 element, 1, 2, 3, 4, 5. This one is still sorted, and there, 1 through 5. That is also sorted. So all of our test cases, we passed them. So that's great, right? That's why we want to write tests. So basically, that's what these slides are trying to say here. Okay, that's optimization number 1. And then optimization number 2, if you remember, is that if we don't swap anything at all in flow largest to the top, that means what? That means the list is already sorted, so we don't really have to keep going, right? And so how would that manifest itself in the code? It's something that you should be able to do. So if you want, pause the video, try to do it yourself first. But here we go. So basically, we're going to have to say, this largest flow largest to the top, it has to tell bubble sort. Okay, did I swap something? Right? If I and then bubble sort here would kind of check. Okay, did flow largest to the top? Did it swap something? If it did, we'll keep going. If it didn't, then we can actually stop. So what we actually do here in the flow largest to the top is that, okay, right at the beginning, did we swap anything? Well, no, we didn't swap anything. So I'm going to have a variable. Remember that we haven't swapped anything. So swap is false to begin with. Now, if we come into here, if this condition is true, that means we're swapping, right? This is the swapping operation. So I'm going to turn on that flag. I'm going to say swap equal to true. Okay, so it will go through, it will do everything, and then the for loop will end. And at the end, I'm going to tell the caller that I swap something. It's either true or false. Okay, and then how would the bubble sort utilize what flow largest to the top returns? Well, it's going to check. So if we did not stop, if we did not swap anything in flow largest to the top, we're done. We can just break. Otherwise, we keep going. Okay, so that's that. And again, we make changes, we should test it. So I'm going to run this, and it does the same thing again. It gives us the same result. So whatever we just did, it's still doing the right thing. Okay, so this is how we introduce the optimization number 2 here. There is a slightly more succinct way of writing this, because we're using a for loop, and then we check inside the for loop. If something is true, we break. So if you can kind of recognize it, it actually kind of looks like a while loop. So we should do this. We should do flow to the top as long as it swaps, right? So that's really can be a while loop. And so we do this while this swap something, we shrink the size, and then we come back here and do this again and again and again until it no longer swap anything, at which point we're done sorting, and and this returns false, right? If it doesn't swap anymore, this returns false, and then we exit the while loop. So this is sort of an optimization on top of an optimization, just to make the code a little more shorter, more succinct. If it makes sense to you, do something like this. If it doesn't help you, if it confuses you, maybe the previous version using the for loop will make more sense. But having done this, let's run this to make sure it actually does work. So, and it again, all 5 of our test cases looks like it works. So that's great. I think that's what all these slides are trying to say here. Yeah. And this is the more using the while loop. Okay, so I think I've gone everything that I want to kind of, I kind of want to talk about with bubble sort. So it's your turn. So the first one should be a fairly straightforward one. We just sort it in the ascending order. So we start with something small and it gets bigger, right? So how do you do this in a descending order? From the largest to the smallest. So should be fairly straightforward. Pause the video, give it a try. If you have trouble with it, post in the discussion forum. Let's discuss this. Okay. All right. Second exercise. Now this would take a little more maybe kind of thinking. Okay. What I'm asking you in this case is, what is the worst case scenario for the bubble sort? Specifically, how many swaps would it take to sort an entire list of size n? So let's have a size, right? Size n. N could be, 5, 10, a million. How many swaps do we have to do in the worst case scenario? So think about this for a moment and see what kind of answer you would come up with. All right, so let's actually look at this. What is the worst case scenario? Well, the worst case scenario is we have to swap like every single one of them, which means this condition is always true, right? Then we have to swap. We always come in here, and we'll have to do this all the time. So what would actually give the worst case scenario? The kind of list that gives the worst case scenario is this kind of list. It's the kind of list that is sorted, but in exactly the opposite way, right? If this list is already sorted descendant, then when we try to sort it in the ascending order, then we'll have to bubble 5 all the way to the end, and then we'll have to bubble 4 all the way to the end before the 5, and then 3 again all the way to the end, and right. So it does a lot of swaps. So what happens is, well, I have the example I have is it's a smaller one. So in this case, 4, 3, 2, 1, the first round it takes 3 swaps, right? Every single step we have to swap. Second round it takes 2 swaps. Third round takes 1 swap. So the total is 3 plus 2 plus 1, and that's 6 swaps. So in general, if the list is size n, then the worst case scenario is basically we start at 1 less than the size. So n plus n minus 1 plus n minus 2, and so on and so forth until the last round, which is 1. So I know we've done the sum of this thing. And there is a formula for the sum series, and basically that's n times n minus 1 divided by 2. And the important part is we actually have 2 n's in this formula, so that's roughly equal to n squared. So what that means is when let's say the size of the list is say let's say 4. It takes roughly 4 square number of swaps. Well, not exactly, it's divided by 2, but that's roughly what it is. Now when the size of the list grows to 5, then it takes roughly 5 square, which is 25 number of swaps. So this kind of function, and then when the size becomes 6, then the number of swap is 6 squared, and that's 36. So this kind of function grows very fast, meaning if the size of the list kind of becomes slightly bigger, the time it takes to sort it becomes a lot bigger. This is kind of a topic that we'll talk about more in 3C, but this is just kind of a preview of the efficiency of an algorithm. And like I said, bubble sort is probably one of the slowest sorting algorithm. Anyway, next question for you to try to do this. How do you modify bubble sort to sort a list of strings, right? Because what we did previously is to sort a list of numbers. So how do you sort a list of strings? So pause the video, think about it, give it a try. All right, so if you actually try this and you were actually successful, your answer will be nothing. You don't need to do anything. Bubble sort sorts numbers as well as strings, right? And the reason for that is really this comparison. The good thing, the great thing about Python is that there's no type, right? At least in the code. Well, there's a type in the runtime, but in the code, there's nothing that says the thing in this list are numbers or strings or other things. So as long as we can compare two elements, two elements in the list using the greater than sign or the less than sign or whatever the sign operator that you actually use here. As long as that type supports a comparison operator, this code would just work. And in this case, for strings, you can compare two strings using the greater than operator. So it works. Now, what does a string greater than the other means? Well, I'm trying to remember. We kind of touched on this a while back. But basically, yeah, you can compare strings like A and B. Well, in the alphabetical order, A comes before B. So when you, what that means in Python or in most programming languages, letter A is actually less than the letter B. And then if you have something like a multi letter word, then you compare the first letter first. And if the first letter is the same, then you compare the second letter, and then so on and so forth until you actually find an order. In this case, cap and cat, they differ in the third letter, and P comes before T. So cap is considered less than cat. So that's how it kind of works, that it's able to sort strings without any change. And you know what? Let me just demonstrate that because I keep telling you this and I haven't shown it. So here I just basically have just letters, and they're out of order apparently. And if I just bubble sort them, and if I run them, they're sorted now, A, B, C, D, E, F. Okay, so without changing my bubble sort implementation at all. So that is really the beauty, or one of the many beauties, of Python's dynamic runtime type system. Last exercise, it's kind of interesting that if you kind of pay attention, you know that the bubble sort that we just wrote, it actually sorts the list, the parameter in place, meaning when we sort this list itself, okay? Sometimes that's what you want, sometimes that may not be what you want. Sometimes you might just want to sort a copy of the list. You don't want to change the original list. So kind of the question here, the exercise here is how do we sort just a copy and not the original list? And the hint for that is you can actually create a copy of a list by using list slice. All right, so give that a try. This one is a little more involved. I actually don't have the solution right here, but feel free if you want to discuss that in the discussion forum. All right, that's the end of this video.